Alright, and welcome to Absolute Value Inequalities, Level 3. Now, I want y'all to take a look at problem number 1 to the right, and notice that it's a little bit more complicated than either our Level 1 or our Level 2 video. So, the question becomes, what do I have to do as my first step? Well, we have to get our absolute value bars by themselves. So, we ask ourselves, do I get rid of my multiplication or my addition first? And if you said addition, you would be right. So minus 4, and that zeroes out. We could say, okay, well 1/3 absolute value x minus 3 is less than 19 minus 4, which would of course be 15. Now wait a second. Are my absolute value bars by themselves? No, because we still have that 1/3. So the question becomes, how do I get rid of a fraction whenever it's being multiplied? Well, we don't want to divide by 1/3. We want to multiply by the reciprocal. The reciprocal of 1/3 is 3/1. Let's cancel. But I hope you would notice that 3/1 is really just the same thing as 3. Okay, so we now have the absolute value of x minus 3 is less than 15 times 3 would of course be 45. Now from here, what do? Well, we get rid of our absolute value bars, and we also notice, wait a second, it's a less than symbol. And pause the video, really think about this. When it's less than, is that our and statement or our or statement? And of course, in this case, it's our and statement. And so we know, okay, well, we're going to write x minus 3 inside our linear inequalities, inside our inequalities, and this 45, since we took away our absolute value symbols, must become the plus or minus version of itself. I'll say negative 45 is less than x minus 3 is less than positive 45. And wait a second, how do I get the x by itself? Well, I simply add 3 in every location, to the left, to the middle, and to the outside, and I get this. I get negative 42 is less than x is less than 48. And all I have to do is come down to my number line, label my negative 42 and circle it, label my 48 and circle it, and think about this. When x is in between both of our inequalities, all of our solutions are in between. Notice that I did not shade in our circles because when it's just less than, we know that negative 42 and 48 are not included. And if you were to ask yourself, well, where are some of my solutions? Say literally anything in here in between on this red and blue shading is a solution. You wanted to pick 0, that would be a solution. You want to pick 17, that would be a solution. You want to pick negative 38, that would be a solution. What are some things that would not be a solution? Well, we know that negative 42 is not a solution. We know that 48 is not a solution. Anything to the right of 48, we could say like 100, not a solution. Or even way over here, we could say like negative 50, not a solution. Okie doke. Let's go ahead and move on to example 2. Okay, and welcome to example number 2. Now notice that my absolute value bars are not by themselves. Okay, we need to get them by themselves. And one quick note, when you look at this symbol, we notice it's a less than symbol, and you might be thinking, wait a second, you know what, I already know that this is an and statement. And I want you to think about that. Is that correct? Could you see any reason why this might not be an and statement? And if not, let's just continue for the moment. Okay. So I have to ask myself, what do I get rid of first, my multiplication or my subtraction? Of course, we know we're going to get rid of our subtraction by adding 7 to both sides. All right, so now I have negative 3 is less than x plus 4 is less than or equal to, negative 3 absolute value x plus 4 is less than or equal to negative 21, because negative 28 plus 7 is negative 21. Now from here, I notice my absolute value bars are still not by themselves, so I'll just divide everything by negative 3, and that goes away. Now I finally have my absolute value bars, x plus 4, by themselves, and I even notice that negative 21 divided by negative 3 is positive 7. But wait a second. What happened when I divided by negative 3? What happens to my inequality? Well, my inequality has to flip. And so instead of a less than or equal to, we actually have a greater than or equal to. And wait a second, that's not an and statement at all. That's an or statement. So remember, at this point, we now have to write this out twice. We'll write x plus 4, and we'll write over here, we'll write x plus 4. And in both cases, we can say, okay, is less than, my 7 has to become plus or minus 7, so it's less than negative 7, or it's greater than positive 7. And from here, of course, I just solve for my x values. Minus 4, we get x is less than negative 11, or minus 4, x is greater than positive 3. Now I ran out of room to draw my number line, so go ahead, pause the video, finish taking your notes, and once you do that, why don't I just go ahead and draw my number line right up here. And we'll even make this nice shade of green, give it a little color. And we see, okay, negative 11 is over here. We see positive 3 is over here. I can circle them both. And wait a second, if x is less than negative 11, I have to shade to the, let's use a different color, I have to shade to the left. And if x is greater than 3, I have to shade to the right. Okay, since neither one of these circles are filled in, we know that they're not included in the solution set. You could get as close as you wanted to. You could get to negative 11.000001, and that would still be a solution. But the second you hit negative 11, that is no longer a solution. Same thing over here. We'd say that 3 is not a solution because it's not included, but you could get as close as you wanted to. You could get to 3.00000001, and you know what? That would definitely be a solution. Remember, anything in between is not a solution. So for example, we could say 0, not a solution, 2, not a solution, negative 7, not a solution. Alright, I hope this has been helpful, and I'll catch y'all in our next video.